Now we are going to deal with the examples of power function, and the power of the variables will be in negative numbers, as you can see from the figure and from the first example. So what's the first example is saying that it we can write it in this form or in this form as well, and from this fraction form we can deduce its domain and range. So what we have to do is simply put the values and check either it's give a simple defined answer to y or not. So if we put 1 into the x value, we will get a simple answer that will be 1. And what if we put 2 into the x, we will get 1 over 2, that will be the value of y. But if we put 1 over 0, we will get an undefined answer. It means that our domain must not contain the value 0. So that is the domain, and we can also put the values, negative values in this fraction or in the value of x, and we can simply get the answer. So how we can reduce the range? That you can see that we cannot put 0 in denominator, and 1, that is the constant number that is already present in that. And if suppose 1 is not present over here and we have some value of this kind 0 over 2, then we can say that our range can have a number that is 0. But in numerator you can see that we already have a number that is constant, that makes it non-zero value. So our range will also not contain the number 0. So next we are going to plot a graph of x raised to power minus 2, or you may write it as x 1 over x square, and that is our power function. So simply we can use the value from the real numbers and plot our graph in here. As you can see that we should not put the 0 in x because it will get an undefined answer, and similarly in range as well we should not put 0 because we already have a constant value in our numerator that makes it non-zero. So we have to use the values that are other than 0. Suppose I am taking x as 1, then I will take the value minus 1, and you can see that it is a square over here. We will always get a positive value in the y. Whether we put negative values in x or positive, we will always get a positive value for y, or you may say that the value of function will always be positive. So we will plot these 4 points and we will check the answers. So first of all, when I put 1 over here, let me erase it and then see, and you can see that the square of 1 will always be 1, and the value of y will also be 1. Let me change the color so that it will make a little bit more colorful. So next I'm going to use negative value of 1, and as I said before that our y will always be positive, and that will be positive. Next we can put the value of 2 over here, and we will get 1 over 4 in here, and we can see what will make it. The 1 over 4 will be 0.25. So our value of y is 0.25, and again we don't need to put the value of -2 because we already know the answer will be same, and it will also be in the positive because we are having a square. So after putting all the ordered pairs in our graph, we will get a simple figure that shows the graph of x raised to power -2. So you can see that we should not put the value of 0 and 0. So simply put 1 and 1 over here, and here is our 1 of x and y axis, and then we are going to plot x equals to 2, and then we will get an answer that is 0.25. Suppose we are having this value over here 0.25, we need a bit more ordered pairs to make the exact graph. At first we will draw these and then the others, and you can see that when we have negative value of x, that is -1, again we will get a positive answer in here, and when we put -2 over here, we will get this. So somehow we have a figure that makes a pendant position of both points over here. So if we use more ordered pairs, then we will make the exact graph. So these are two power function examples with the negative values.